What do you hear when you think of a scientist? When you think of that word, what stereotypes come to mind? If you're like many people, when you think of a scientist, you'll think of somebody who has memorized a lot of facts, a tremendous amount of wealth about our world and the way it works. You might think of a physicist who can describe a black hole in a tremendous amount of detail. Or you might think of a biologist who can draw the structures of all 20 amino acids with great care. However, that's not what makes a good scientist. You also might think of somebody who can repeat experiments over and over and over again, the classic experiments that were done by the giants of science before them, and get the exact same result every time. But that is not what makes a good scientist or what trains our scientists of tomorrow. This type of science is a science we have approached and used too long in the United States. It's a type of science I'd like to define today as knowledge-focused science. And it's a science that is failing us. It is not serving us well. As evidence of this, the Pew Institute recently, a few years ago, came out with a study where the students in the United States ranked 24th in science education throughout the world. Again, knowledge-focused science is failing us. I'm not the only one who has noticed this. Many states, funded by the Carnegie Institute, have come out with a new set of standards for science education for K through 12. They're called the Next Generation Science Standards. And what they do is they focus on the three things that you see within this triangle. So instead of focusing on facts and repeating experiments, we want to focus on these three items: core ideas, cross-cutting principles, and practices. I'd like to delve into this a little bit to describe what's going on. In knowledge-focused science, we focus on facts. But in the new generation of science, we're going to focus on disciplinary core ideas. For example, instead of drawing all 20 amino acids with great care, that's not something we really have to worry about nowadays. When I was a student, we had to worry about that. Otherwise, I had to run to my textbook and look it up, and it took a lot of time. Today, I can just look up the structures on my phone in a matter of a minute. I'm not saying that knowledge is not important, but it should not be the emphasis of science education. Rather, we should be focusing on core disciplinary ideas. Instead of the structures of the amino acids, it's more important to know how proteins fold, because the amino acids are the building blocks of proteins. That knowledge of that core idea can help students tackle novel scientific problems much better than any fact could. These new generation standards also talk about how instead of looking at facts, we should talk about cross-cutting principles. Principles or themes that transcend all the sciences. For example, there's a principle in many sciences called structure and function. In anatomy, that might look like this. The structure of your bones and your muscles enable the human body to move and work in a certain way. But this theme transcends the sciences. In engineering, structure and function can show how an engineer better have proper designs to build a structurally sound bridge. Again, if we don't focus on the facts, but rather we focus on these cross-cutting principles, what we can do is empower students to have the ability to tackle novel scientific experiments and inquiry. Finally, these new standards say instead of focusing on experiments, instead of repeating the experiments time and time again that the great scientific minds have done in the past, we should focus on allowing students to practice original scientific inquiry. There is no need to repeat those previous experiments time and time again. We know the results. We know what's going to happen. But rather, we want to empower students to be able to tackle science and practice original inquiry and contribute new original data to our world that will impact our society. All of these new ways of looking at science, I'd like to pull them together and define them as something I'd like to define as process-focused science education. And I believe it's something that's going to impact our world greatly and change our world. How will it do that? I believe that process-focused science education is going to increase innovation. As evidence of this, a recent study indicated that the average age of a new investigator who receives a grant from the National Institute of Health in 2008 was 42 years old. About 3 decades earlier, the age was only 36 years old. So we increased in age of a new investigator the first time they got their first science funding over that 30-year period. by 6 years. Over that same 30-year period, if you looked at all the Nobel Prize-winning scientists in science, in biomedicine specifically, the average age was 41 years old. There's a disconnect there. If the average Nobel Prize-winning scientist is winning their Nobel Prize for research that they did when they were 41, but we're not going to fund them to do that research until they're 42, that's a problem there. And it's because we're focusing too much on knowledge-focused science education, the result. If we shift to process-focused science education, it's greatly going to enable students to participate in science at an earlier age. The young mind has tremendous creativity. Not saying the old mind doesn't, right? But the young mind has tremendous creativity. And it's not confined by the dogmas of science. So it would behoove society to allow students of science to participate in original scientific inquiry throughout their whole career. So we don't want to wait until they accumulate a certain amount of knowledge to let them play the game of science. Rather, if we focus on process-focused science and teach them those core ideas, those cross-cutting principles, and allow them to practice science, they can contribute to science throughout their lives. Also, I believe that process-focused science education is going to accelerate research by lowering the barriers to entry. Recently, about 5 years ago, there were a group of HIV researchers that were trying to come up with the structure of an HIV protein that was involved in HIV replication. Remember, HIV is the virus that causes AIDS, which has been a worldwide pandemic for the last 3 decades. For years, the structure baffled the scientists. They couldn't figure it out. So what they did was they developed a game, an online game called Fold It, where online gamers with this program and empowered with core ideas about how proteins fold, not the details, but core ideas, could try to tackle this structure. They opened it up to the gaming community. Within 3 weeks, these online gamers solved the structure of this protein that science was baffled about for over a decade. I also believe that process-focused science education is going to empower our citizens to advocate for themselves. For example, it's going to allow citizens to demand that there is truthful execution and reporting of science, the science that they pay for, that's publicly funded. You might say, why is this a big deal? Well, a recent study has shown that the amount of papers that have been retracted due to either fraud or error over the last 2 decades has increased dramatically. If citizens understand the process of science, they can demand that science be executed in a proper way. Process-focused science is going to allow citizens to advocate for themselves and their family as well. Whether it's issues of healthcare, deciding, does this medication have a bad side effect, does it not, communication with their physician, or if it's issues of the home or lifestyle choices, should I purchase that home that's next to that industrial area? What effect will that have on my family and I? If someone understands the process of science, it will empower them to work with others, gather knowledge, but then interpret that knowledge for themselves. It will also allow people to engage in scientific policy better as well, to direct the science that they're paying for to answer the questions that their society or their region needs. So in all, you could see that I think process-focused science is a great shift that we are making and that we need to continue to make, away from knowledge focus, but towards this process-focused science. It aids in student learning. That's one thing I've noticed in the classroom as a university biology professor. It aids in learning tremendously. Students are more engaged, they're more interested. So the question then is this: if process-focused science has all these great benefits, how do we accelerate this shift from knowledge-focused science education to process-focused science education? What we need to do is we need to free the time, we need to empower students, and we need to provide them the mentorship from individuals who know how to tackle science from a process-focused philosophy. At North Park University, my home institution, that's exactly what we're doing. Administrators, faculty, staff, students, and the whole campus community has come together to re-envision our course schedule for next year, for the fall semester. And what that looks like is we've freed up Wednesday afternoon, a nice 4-hour block of time where students can engage in experiential learning. In some disciplines, that might mean going out into the city to tackle certain problems or see certain questions firsthand. In the sciences, what that means is we have a large block of time for students to do original scientific inquiry. And what I like as a biology professor is it is going to allow them a tremendous amount of time to repeat their experiments over and over and over again. My students might shudder at that thought, but I like that. But here's the key. They're not going to repeating experiments over and over and over again that others did. Right? We don't need to do that. We know the results. We're going to empower them to engage in new scientific exploration, and they're going to be repeating experiments of their own choosing. And by doing that, we're telling our students that we trust them. We trust them and their abilities to contribute to new scientific data that's going to impact our society in a positive way. I think the famous psychologist, the developmental psychologist and child psychologist, Jean Piaget, said it best. Scientific thought is not momentary. It is not an instance. It is a process. And by focusing on process-focused science education, by emphasizing that, I believe that the results will come. Thank you.